So, friends, welcome to this lecture series of geomorphology, and today we will continue with this fluvial process, particularly the drainage pattern. So, if we summarize the last class here, the drainage pattern that we are discussed, it is there are two types, one is basic type and modified basic type. Basic type means that from one drainage pattern to another drainage pattern we can identify, we can distinguish easily. But modified basic, it is within a basic type there will be certain modification. So, that is called modified basic type. For example, if we say it is a the dendritic drainage pattern and subdendritic drainage pattern. Dendritic drainage pattern means you can distinguish the dendritic from the surrounding, either a trellis, it may be some radial or something else. So, that means at a first look, at first instance, you can distinguish a particular type of arrangement of drains or arrangement of channels from the other parts or from the surroundings. And modified basic means within that particular type. So, for example, the dendritic pattern, there will be some parallelisms, some local parallelism will be there, some local radial drainage will be there. So, that means it is within that. So, that is called modified basic. So, today or in this class we will discuss about the different drainage patterns, that how these drainage patterns are useful in interpreting the subsurface, interpreting the climate, the tectonic process, the faulted, jointed, folded rocks, or it is uniformly dipping, uniformly sloping surface, and it is alluvium or hard rock, porous, imporous, impervious rocks. So, that means the geological characteristics of the subsurface as well as the geological characteristics of this climatic component, how it is a arid zone drainage, it is a humid zone drainage. So, depending upon the drainage pattern, by looking these drainage arrangements, distributions, we can say about climate, we can say about tectonism, we can say about lithology, we will slope, it is faulted, folding, or whatever the geological structures are there. So, all these things can be interpreted from this first look or drainage analysis and by looking at the drainage pattern. So, let us start with the most common type of drainage pattern that on the earth surface, what is called dendritic drainage pattern. It is the most common one, most common drainage pattern everywhere, and it is present. And the dendritic, this term, it is from the Greek word, it is dendrite, and it is like a tree. So, this is the ideal figure of a dendritic drainage pattern. So, if you see here, these are looking like branches of tree, and they are meeting the trunk river or the main river. This is the trunk river or the main river, and each tree branch, it is meeting to this trunk river. This is showing the dendritic drainage pattern. So, they develop where river channel follows the slope of this terrain. Dendritic systems form in V-shaped valley. As a result, the rock types must be impervious and non-porous. Here, the geological interpretation is there. The rock type will be impervious and not porous, not permeable. So, it is a flat, either it is a basaltic terrain or it is a granitic terrain or it is any terrain which is gentle slope, and it is mostly impervious and impermeable rock. So, that is why a number of streams on the surface will be more, and that is why the surface drainage will be more as compared to subsurface percolations. So, here there is some modification, that is called subdendritic. That means, the whole river system or the whole channel system, drainage system, it does not show purely of dendritic characteristics. That is why it is called subdendritic. For one example is there, along the lower Yellowstone river in eastern Montana, the dendritic pattern is slowly developing trellis characteristics, under the influence of a prevailing system of poorly expressed joint. So, that means subdendritic means you see here this is showing trellis characteristics. So, that means though it is totally a dendritic system, but locally there are certain parts, certain regions they are showing trellis pattern. Similarly, somewhere some local part may show some other pattern also. So, that means the whole drainage system is not of dendritic characteristics, that is why it is called subdendritic. So, it is modified basic. Basic is dendritic pattern, subdendritic is the modified basic pattern. Deviations are presumably due to secondary regional control, either structural or topographic. So, here this local changes, local deviation may be structurally, may be topographic. So, climate cannot affect, because climate if affects a large area, you cannot say this river or this part of the river is climatically affected, then this part is tectonically affected, no. So, that is why when we are talking something about local changes within the drainage pattern, as if you remember in the last class we are talking about the drainage anomalies. Anomalies mostly they are tectonically contributed, tectonically influenced. Similarly, here this local changes, local modification from the basic type, this is subdendritic pattern, it is either due to this is secondary regional control, either structural or topographic. So, structure and topography they affect locally to modify the basic pattern to this modified basic pattern. Then the second type of drainage we will discuss about the pinnate. Pinnate is the pattern characterized by many closed spaced more or less parallel tributaries entering the large stream at an acute angle. Here if you see this figure, it is very closely spaced drainage and they are more or less parallel. If you see this these tributaries are more or less parallel tributaries. They are entering an acute angle to the main drainage. This pattern is best developed in fine textured, easily eroded materials such as loess. So, here is the interpretation. It is fine textured material, it may be loess, it may be fine sand, silt, fine textured material, easily eroded material again, they are easily erodable. So, that means gully type of appearance, that means gully type of development will be there, or that is gullies or valleys type, that means which we remember our last class we are talking about this rills, gullies and valleys, mostly it is gully type of appearance, and here fine texture will be there and mostly more erodable material will be there. The fine texture of this material accounts for close spacing of these small tributaries, and steep valley sides are the cause of their parallelism. So, again the geological interpretation, once we said it is fine textured, that means it is close spacing, this fine textured material that will account for close spacing of drainage, and parallelism is due to steep slope. See, more the steeper slope, the more parallel the drainage are. So, if you remember last class we are talking about this Piedmont zone, the Himalayan Piedmont or any Piedmont zone worldwide, if you move, they show steep slopes, and these steep slopes they show parallel drainage pattern. So, this parallel drainage patterns they are characteristics of slope, and mostly it is steep slope shows parallel drainage pattern. So, here we have parallel drainage pattern, that means indicating it is a steep slope. Then we have fine drainage pattern, very fine drainage pattern, that indicates it is a finer and easily erodable material like loess. Then anastomosing river system. Anastomosing river, last class we are talking about like the channel habits. Anastomosing, that means this channel is bifurcated or multifurcated channel are there. This channel they enclose or permanent islands, and this channel remains stable. Similarly, it is anastomotic drainage pattern. It is characterized by network of interlocking channels, sloughs and bayous and oxbow lakes is found in floodplains and deltas in tidal marshes. Floodplains, it is very good example is the Ganga floodplain. If you see this satellite imagery of Bihar area, mostly the eastern Bihar, you will find this type of structures very well preserved systems. It is there in the satellite imagery due to frequent migration of rivers. You find thousands of oxbow lakes, thousands of paleo channels are there. So, here it is the characteristics is interlocking channels, loss waves and oxbolex. It is found in floodplains and in deltas in tidal marshes. So, this geological interpretation is it is found in floodplains and in tidal marsh in deltaic area. Then another type of drainage pattern is the distributary pattern. Distributary means the term itself says it distributes. That means the main channel it distributes its water through distributary channels, sub channels. So, these are mostly found in alluvial fans and in deltas. So, alluvial fan and delta they are the characteristics drainage pattern of distributary pattern. So, here alluvial fan and delta is there. It resembles the dendritic pattern except that the tributaries diverge from rather than converge towards the mainstream. The difference is that in a drainage pattern like the dendritic where the tributaries they converge in the mainstream, but here these distributaries they diverge from the mainstreams. Then parallel drainage pattern. Parallel drainage pattern again a few minutes back we are talking something about, it is talking about the relief, the slopes, higher the slope, higher the parallelism. So, this parallel drainage system is a pattern of river caused by steep slope with some relief, steep slope. Here if you see this block diagram it is given, it is slope is like this. So, you see these parallel drainage patterns are there. So, steep slope with a some relief will be there. Because of the steep slopes, the streams are swift and straight with very few tributaries and all flow in the same direction. This system forms uniformly sloping surface. Parallel drainage pattern form where there is a pronounced slope in the surface. A parallel pattern also develops in the regions of parallel elongate landforms like outcropping resistant rock bands. So, here when there is a alternate hard and soft rocks. So, soft rock will easily erode and it will accommodate a channel within that, and hard rock will remain resistant and it will serve as a ridge. So, this type of parallel drainage pattern also it is seen in the regions where alternate hard and soft rocks are exposed. So, this is the geological interpretation. First is it should be steep slope with some relief, and second interpretation is it may be due to alternate exposure of hard and soft rocks. So, but the main thing whether which region is the most one it will be studied in the field, examined in the field. Then subparallel, that means parallel is the basic and subparallel is the modified basic. The subparallel pattern shows less parallelism than its basic pattern, it should less parallelism. If due to slope alone the pattern resembles that formed by these branches of a polar tree, where due to mild structural control by deformed strata of relatively uniform resistance to erosion, there is sufficient parallelism among these segments of this mainstream and tributaries to suggest the bedrock control, but streams commonly diverge from the geologic grain. So, here this subparallelism, that means it is not perfectly parallel, but resembles to parallel. Here for example, if you see these streams they resemble parallel, but not exactly parallel. Then colinear, colinear means in the same straight line, colinear in the same line. So, here if you see this drainage, somewhere it is exposed, somewhere it is exposed and somewhere it is not exposed to the surface. So, that means within a line of drainage, within a line of channel, some part of the channel is exposed and active and some part is not exposed, that is within that subsurface. So, this pattern is characterized by remarkably straight parallel streams or channels which alternate disappear and appear. Here this key factor is there, alternate disappear and appear. For example, here this is appear and in this is white portion is disappearing. Similarly, the black line it is appearing and the white portion is disappearing. So, within a straight line appearing and disappearing, appearing, disappearing, appearing, disappearing. So, this type of drainage pattern, it is called colinear drainage pattern. This pattern is found in areas of linear loess and sand ridges. Loess and sand ridges, if you see loess, it is porous and permeable, and sand is porous and permeable, but loess it is porous but not permeable. In that cases, if you have alternate sand and loess, so in that case, so that means sand clay. So, this sand clay alternative sequence is there. So, in that case you will find in clay pattern this, though it is porous but not permeable. So, water will not percolate down, it will be on the surface, but in sand regions this it is porous and permeable. So, water will percolate down and there will be disappearance of drainage. So, alternative loess and sand ridges if it is there, so you will find such type of colinear drainage pattern. Then another is your trellis pattern. Trellis pattern, this occurs where a subparallel stream erode a valley along the strike of these less resistant formations. Here if you see, these are the ridges, these shaded areas, they are resistant ridges and these are soft rocks. Now, you see these soft rocks, they can easily erode and will accommodate a stream in between inside, it will accommodate, and as it is hard rock, this is hard and this is hard. So, there will be a steep slope gradient will be there, steep slope will be there. So, due to the steep slope, you see this type of parallel streams, they comes from the steeper area and join to the main stream. So, this pattern is called trellis pattern. These beds are usually steeply dipping and may be part of a folded system. The tributaries often intersect at right angle where a notch called water gap cuts through a harder formation. This is called notch or water gap. Here the streams are meeting. Similarly, if a ridge will be there, here will be the water gap. A stream may come here and meet here. Okay. So, trellis pattern it indicates it may be a folded terrain, it may be alternate arrangement of this hard and soft rock, and the hard rock remains as resistant and it is steep slope. So, due to the steep slope, small tributaries they originate from these steeper slopes and meet the main stream at right angle. Then within the trellis pattern, there is some modified basics. Trellis is the basic pattern. Modified basic is one is called directional trellis. Directional trellis means that means it is indicate it is in one direction, directional trellis. This term suggested for a modification of the trellis pattern in which the tributaries to the long subsequent streams are consistently longer on one side and in the valley than the other. For example, if you see here in this figure, it is directional trellis, that means one side of this, see this is the main stream and these are the tributaries. This side the tributary is smaller, however, this side the tributary is longer. Similarly, this side is the tributary is longer, this side is smaller. So, that means it says here this side is longer and this side is smaller. So, that means it says though it is a trellis pattern, but one side of these tributaries are much longer as compared to the other side. The pattern most commonly is found in areas of gently dipping homoclinal beds, but also occur on gentle slopes with parallel beach ridges. Beach ridges we know in the earlier classes when we are talking about this coastal geomorphology. So, need not to talk much about this. So, this type of drainage pattern there is characteristics in beach ridges as well as the tributaries subsequent streams it is found in the gentle slope, parallel beach ridges and homoclinal beds. These are the geological interpretation. Then within the trellis another sub pattern or this modified basic is sub trellis. Sub trellis means the sub trellis pattern differs from this type trellis pattern only in the degree of continuity and parallelism of this dominant drainage. distinction between subtrellis and subparallel is commonly a matter of judgment. So, here the geologist has to decide on which category he or she has to put this drainage pattern. Then it is called curved trellis. Curved trellis means this is a modification of this trellis pattern in which the pattern as a whole forms a sweeping curves around the notches of plunging fold. For example, here if you see this is a plunging fold and the drainage system is like this. So, the drainage that will here that will modify like this, it will continue, that drainage itself will fold like this. So, this is a pattern here, it is a modification of this trellis pattern in which the pattern as a whole forms sweeping curves around the noses of a plunging fold. So, here if you see this is modifying, similarly this is. So, it is a noses of a plunging fold. So, if it is folding like this, the drainage system is curved like this. So, this is called curved trellis. Comparison of the length of small tributaries on opposite sides of the curved subsequent streams, particularly at a nose of this fold, commonly permits distinction between plunging anticline and syncline. So, you can distinguish from a drainage pattern of this curved trellis, you can distinguish whether you are dealing with a antiform or synform, it is in plunging antiform or plunging synform. The direction of flow of these longer tributaries generally indicates the direction of dip or direction of plunge, you can say it is a direction of plunge of this fold. So, here if you see here this drainage, you see it is flowing in this direction, it is flowing in this direction and will curve somewhere here, it is curved somewhere here, it will curve somewhere here. So, this direction of a flow is towards the plunge of this fold. Similarly, here if the drainage pattern is developing, for example, if you see here these are the drainage pattern develops. So, that means it indicates this, it is a plunging fold and the plunge is to this direction. Then another type of trellis pattern, it is a modified basic type, is fault trellis, that we have fold trellis, that is curved trellis. Similarly, we have fault trellis. So, that means it is a trellis pattern, but it is controlled by fault. For example, if you see this pattern has been attributed by Dake and Brown in 1925 to alternate grabens and horsts of succession of parallel rifts. So, we have horst and grabens. So, horst and grabens, we know grabens, they are a depressed part, it is bounded by normal fault, and horst, they are in uplifted block bounded by two normal faults from both sides. So, that means we alternate, we have ridges and basins. So, and we are generating here this fault trellis, that means it is a fault are there, fault graben horst, that means always normal fault is associated. It is described as less closely spaced than the trellis pattern on tilted or folded strata, which tendency towards dendritic pattern between these faults. Right angle turns are also less common. The fault controlled streams, although grossly parallel, locally diverge, converge and branch, and these broader interstream segments show dendritic, radial and other drainage patterns. So, these are the characteristics within this fold, within the horst and grabens. So, here these streams, they are totally fault controlled. So, once they are fault controls and we have horst and graben, so grossly they will show parallelism, but they locally diverge, converge and branch in broader interstream segments. So, dendritic patterns, radial patterns and other stream patterns. Within the interstream segments, they can show different type of stream patterns, but broadly they are parallel with each other. So, they are fault controls, and this parallelism that depends upon the length of this fault, to what extent the fault is continuing. Okay. Then another type of modified basic of trellis pattern, it is the joint patterns or this joint trellis. Joint trellis, a fracture trellis pattern characterized by short remarkably straight parallel streams may be referred to as joint trellis, although the fractures may include faults also. So, here if you see these are these joints, that means one set of joints, for example, it is nearly east west. For example, here if this is we consider north. So, here it is east west joint sets are there. Similarly, another set of joint, if it is coming here, another set of joint is coming out. So, that means here this trellis pattern is developed due to these joints of rock. The fracture trellis patterns differ from the rectangular pattern in having one dominant set of parallel streams. One dominant set of parallel stream is there. Then another type of drainage pattern, that is called rectangular drainage pattern. Rectangular means this rectangle itself is looking like rectangle. For example, here if you see this is rectangular pattern, similarly here it is rectangular pattern. So, this rectangular pattern, that means it is also structurally controlled. If two sets of joints are there, two sets of joints, they are cross cutting each other at the right angle to each other. So, this type of drainage pattern can develop. So, here a drainage pattern in which the main streams and their tributaries display many right angle bands. So, this right angle bands, so it is indicative of stream flowing prominent fault or joint systems that break the rock into rectangular blocks. So, either it is fault system, two different sets of fault, two different sets of joint which are perpendicular to each other, this type of drainage pattern will accommodate there. Rectangular drainage develops on rocks that are of approximately uniform resistant to erosion, but which have two direction of joining of approximately right angle. So, here the interpretation is there. So, here uniformly resistant rock to erode. So, one characteristic is there. Another characteristic which is structural control, that means two perpendicular joint sets or faults, they are controlling the whole drainage system. As a result, here you will see the rectangular bands are there. Then angulate means angle. So, this pattern is characterized by numerous acute angle bands and braided tributaries. So, here acute angle bands are there. If you see here, this is acute angle bands. So, this is angular types, acute angle band. If you see here, this is bending, this is bending. So, this is generally found in areas where an additional set of this fracture is superimposed on a rectangular set. So, here we have rectangular set, and on this rectangular set we are superimposing another set of joint which is at an angle to that. So, there may be two superimposed rectangular system on different orientations. So, that means if the drainage system is structurally controlled, we are getting a directional trellis pattern. So, that means at particular directions they are confined, and the direction is defined by the structural system. It is defined by this fault pattern, it is defined by this joint orientation, different set of joints, either they are parallel to each other, perpendicular to each other, or they are superimposed joints. So, that means structure we can interpret, lithology we can interpret, slope we can interpret from this drainage pattern. That is why drainage pattern is an important parameters in tectonic geomorphology rather than geomorphology to say what type of terrain you are dealing with. So, I think we should stop here, we will meet in the next class. Thank you.